Now moving into sizing a distillation column. So before starting calculation steps, you're encouraged to gather these essential data such as liquid and vapor flow rates, densities of both liquid and vapor phases, operating temperature and pressures. So the first calculation step is to estimate the minimum number of stages that is required for the separation using Fensky equation. So it is relies on the component flow ratio in the distillate and the bottoms, and also the relative volatilities of light and heavy key components in both streams. So you can get these data and then substitute in the equation. So next we are going to find the minimum reflux ratio. So we are going to use the Underwood equation, and this step is a bit tricky as it involves solving the parameter theta at the beginning, and you have to make sure choosing the correct Q for your case. As for the boiling feed, Q is equal to 1, and for dew point the Q is equal to 0. So once theta is found, after that we can substitute it back to find the R minimum, which is the minimum reflux ratio, in the equation given. So now we can solve the equation. We can find the right hand side by calculating the R value. Since we had already calculated R minimum, so the optimum reflux ratio is approximately 1.2 to 1.5 times R minimum. So by that we can find R, and after that we can get and obtain the right hand side. Once we got the right hand side of the equation, now we can get the left hand side using this graph shown. So after getting the left hand side, we already got the N minimum calculated. So by that we can substitute and solve for the actual number of stages. Next, using Kirkbride equation, we can now determine the optimal feed tray location. It depends on the distribution of light and heavy key in the distillate and bottoms, along with the flow ratios. So this step is a key for ensuring the efficiency. So the next step is to calculate the surface tension factor based on the surface tension of the liquid, and after that we compute the flow ratio parameter, and this tells us about the behavior of two-phase flow inside the column using the ratio of flow rates and densities. So next, using the flow ratio parameter obtained in the step before, we can refer to figure 13.4 as shown in the Process Design Principle book to determine the capacity parameter based on the plate sizing. So this tells us about the capacity per tray spacing under different design configurations. So next we have to calculate the capacity parameter using CSP obtained in the step before, which is the capacity flooding factor, the surface tension, and also the correction factor based on the tray type. Make sure to use the correct factors based on your case, because for non-foaming system it's totally different than a foaming system. So you have to refer for the conditions as you can see in the picture. So next we're going to estimate the design pressure and temperature using operating condition. So depending on the operating pressure range, different formulas or factors are being used. So as you can see, for operating pressure between 0 and 5, the design pressure will be 10. Meanwhile, for operating pressure between 10 and 1000, we are going to use the equation shown. And for operating pressure greater than 1000, so we have to use a design pressure equal to 1.1 times the operating pressure. So to ensure the mechanical strength, we determine the maximum allowable stress based on the design temperature and the weld efficiency depending on the wall thickness and inspection type. So these values can be found in the Cedar book as shown in the slide as well, and more details of the mechanical design will be further explained. So to ensure so last but not least, we calculate the total height of the tower. These include the head space at the top, the tray spacing multiplied by the number of trays, and the sum space at the bottom. So each of these contributes to the overall size of the column, and the head space is equal to 4 feet, which is constant, and the sum space is equal to 10 feet, which is constant. That's all for sizing of distillation column. Thank you.